How we doing? Anyone get there? Nice. Nice. I'll give you a few more minutes. You see something? So we want to be checking on Desmos, right? Nice. Nice. Now, are we okay? Oh, wait. Yep. Does it feel like a ghost town on the campus? Have you been in a summer session before? It's usually packed with other classes and everything. Yeah, because we get students from outside of that are home for summer vacation that don't want to take Calc 2 at you know, at Berkeley. How we do? We get there? Daniel, yes? Almost? Brian got there? Noah, Baruch, Brian, Teddy? Where did you go wrong? Okay, so by part, but by part should, right? You gotta be so organized. Would you like me to do it by parts instead of shortcut so you see it? You just it's about that. So integral. Who cares about my bounds? I don't need that. We're just trying to get the integral right. So x sine x dx. So watch, right? So did you pick x as u as x, Teddy? Okay. So that's this Liate list, right? We gotta make sure we understand this. I see the algebra before the trig. I see the polynomial before the trig, and so that's why I'm picking, right? That's telling me, oh, if you see a log, pick that as u. If you see an inverse first, pick that as a u. Whatever you're seeing in order first, that's your u. So u is x, so that means du is just dx. dv is sine x dx, right? And of course, we know the antiderivative of sine is negative cosine. And so my uv, right? uv is my negative x cos of x, which you can already see in my problem, right? Minus the integral of v du. Well, v is already negative, so plus the integral of cos x dx. And of course, the integral, the antiderivative of cosine is just sine. So there it is. So, but the choice, and the same thing happened with someone else on the quiz where you picked the wrong u. If you picked the wrong u, right, it was Alex. Alex didn't learn it yet, so he's forgiven, right? But I think we had x squared e to the x, or e to the minus x. And so look at the exponentials in my Liate list are last. So if I see anything else first, I have to make that the u value, right? And of course, the tricky one, which I'm going to somehow get on your exam, is x ln of x, because you so want to pick x as u, because it's easy when it's that way. So, but it's right, it's going to be ln of x, because it's Lyautey. L is my first thing in my list. If I see a log, and for me that's always ln. Other teachers will include log base b. I don't, just ln. Okay, now Simpson's rule, right? So we're doing the integral from 0 to pi of x sine x dx with Simpson's rule. And I've got it down on my formula sheet, right? It's delta x over 3, am I right? Anybody have it on their formula sheet already?
Yeah.
Delta x over 3, I need 1 times f of x sub 0 plus, and then I'm going 4 2 4s, right? So 4 times f of x sub 1 plus 2 times f of x sub 2 plus 4 times f of x sub 3. And I'm done because I've only got 4 rectangles, so I'm going to have 5 markings right on my axis. So plus 1 times f of x sub 1. It'd be nice if we drew the picture here. Because we can see, right, if I take my b minus a, so delta x is b minus a over n, right? So and of course I'm talking about the bounds of the integral there. So pi minus 0 over 4, so pi over 4. So I can clearly see labels of 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, right? So I can see my x sub 0, x sub 1, x sub 2, x sub 3, x sub 4. That's an x sub 4 there, sorry. Right? And so the next piece is just a little bit messy, that's all, but that's fine. So I get my area is approximately equal to pi over 4 over 3, right? And then I'm putting in my x sine x values. So 0 pi over 4 sine of 0 pi over 4. It's a little overkill, but I'm trying to be as simpleton as I can and as organized as I can, and not think as I'm doing anything. I don't want to have to be thinking while I'm writing all this crap down, because I'm going to make a mistake. I want to hopefully not have to think at all. Then 1 pi over 4 times 4 times sine of 1 pi over 4. You know, and I'm writing small. You don't have to. You can also stack things. So 2 pi over 4 times another 2 times the sine of 2 pi over 4. Right, trying to be really organized, plus 3 pi over 4 times a 4 sine of 3 pi over 4. And I'm choosing to put the 4 2 4 as the second factor. Who cares what you do? Right, so you see what I mean by like stacking it? I don't have to write it all the way across if I'm finding I'm writing too small. So pi over 12, and then I'm trying to figure out which one of these are 0. Oh, sine of 0 is 0, and it's on, and I'm multiplying by 0. Sine of pi is 0. Everything else is not. So now as I copy it, I'm going to try and simplify, right? So it looks like I get pi times sine of pi over 4 plus pi times sine of pi over 2 plus 3 pi times sine of 3 pi over 4. Do you agree with that? Do you see how I'm trying to be real careful and simple, trying to take baby steps. How is everybody doing? Yes? Tell me, were you confused here? Yeah. Yeah, so the 1, the 4, 2, 4, 1 is coming from Simpson's rule, right? They had figured out the formula for it. I'm always going to have 1 times, right? The first 2, 4, 2, 4, and then it should be ending with a 1. So then I'm plugging into that, right? So I'm plugging in, remember, f of x is x sine of x. So I've got to plug in for the x here, and I have the coefficient from Simpson's rule that's got to come in. Yes, yes. Yep. So 1 times f of x sub 1, whoops, right here, sorry, 4 times that, it's got to be 4 times x sub 1 times sine of x sub 1. Right, and I just switched my 4 and my x value there. Good, I definitely can factor out a pi, right? And then I'll see if I can just, well, I want to rewrite. I don't want to do anything tricky. Right, so sine of pi over 4, I know. If I don't, I look at my circle. Square root of 2 over 2. Sine of pi over 2 is 1. And sine of 3 pi over 4 is also square root of 2 over 2. Yes. So I get 1 plus 4 square root of 2, 4 square roots of 2 over 2, which is nice. You get 1 plus 2 rad 2, right? All times pi squared over 12. Nice. Then I want to go see how good that is compared to my original function, right? My original. Nice. Really? That's good. Nice. So pi squared over 12 times 1 plus 2 rad 2. Everybody's comfortable with the Desmos and typing certain things, square roots, pi, yeah. Nice. Wow. Pretty damn close. A penny off. Less than a penny, right? Yeah. So I want to see, the key is I want to see this work, right? That's what I'm grading you on. Because certainly we could go to Simpson's rule and find we could go to GeoGebra and find one. Let me try it one more time today. I'm starting to believe it really is my OS. Does anybody have one they know for sure they like? Let's try Kunin. Oh wow, this one might be working. X sine x, right? 4 rectangles already. All I got to do is fix my b value for pi, right? Where the heck is my, can I edit B? That's the point I want to edit. Oh, there it is. So A is right, 0, 0, right? B, come on, let me edit. Damn it. I just can't get, can you get in there and edit B on this one? Are you with me here or tell me which one you're using that's working.
It's the you search without the apostrophe.
Yeah,
John Stenger. That's
okay.
what I
Oh, nice. Thank you. Why the hell? I asked you, damn it.
that's second.
What is it? Which one?
John Stenger, second.
Oh, thanks. Ha. Oh, I like it. See, I think it's my computer. You have no problem editing?
Nope.
Yeah, it's probably my computer. And N is 4, right? And then where is it giving me? Where can I do my bounds? Oh, by the dragging, right?
Yeah.
0.
It snaps.
Gotcha.
Snaps up a lot.
Yeah.
At least for me.
3.14. I'm trying to get to 3.14. Oh. Oh, damn it. Ha. Good enough, right? And then where's my sum?
So if you check
Oh.
on area approximation, so
Area there. Okay, so there's the exact and there's my approximate. Let's see if I can get it to 314 and see if it gets better. Ah, forget it, right?
it only gives it the three decimals.
Yeah. So maybe find one, maybe look again, okay? And see if you can get one with a little bit more decimals so that we could check it with our Simpson's rule that we actually do by hand.
See the parameters.
Yeah. Yeah, it's cool. So you see this, the first, there's, when I'm looking at this page here, there's 5 that are the same. That means somebody just copied their applet that they made and then saved it with their name. Maybe they did something else with it. I'm not sure.
It was all the John Stengers.
Yep. Oh, here, this one's pretty good. I can type in 0. Let's see if I can type in pi. Yep. But where the hell is my area down? Damn it. Yeah, it could be mine. It could be mine. I don't know if it's showing up on yours. Did you do that one? This is Joanna Wilson. Will you try that for me, please? And remember, we're trying to see if it will give us more decimal places. Trying to find one that will give us a little bit, some more decimal places in the answer.
I don't really want to do something with myself.
Just graphing it. So no approximate area. All right. Well, I think that right, that the one that we did today is enough. I mean, it's if it's only giving me 2 decimal places, right, and at least I know I'm close when I'm taking the quiz, right? Okay, partial fractions. Yep, partial fractions. We got a couple on the exams we can do. One more time? Oh, yeah. Yes, this one? You need the second half of it? Yep. So there's number 6 on the first exam, and I'm pretty sure we did that one together. I'm happy to do that again. That does have a complete the square in it. And then on our second exam, also has a complete the square in it. Let's do the second exam. Yeah, number 10 on the second exam. It's right after quiz 5.7, partial fractions 2 and 3. So I've got the integral of x squared plus 5x plus 12 all over x minus 1 times x squared plus 4x plus 13. I'm interested in that x squared plus 4x plus 13 right off the bat. And one of the things I like to do is look at it real quick on like Desmos. So y equals x squared plus 4x. What was it, plus 13 or 15? And when I look at it, I see, one, it's not factorable. That's the main thing I'm looking for right here. It's not factorable. So I know this thing, right, is completely factored for me already. So I'm creating this equation, this rational equation of a over my linear factor plus bx plus c over my non-factorable quadratic factor. And I've spaced it out on purpose because I know I'm going in to multiply by my LCD, right? For my favorite part, the canceling. Yes. Oh, I got to multiply it over here too, right? So I know a whole bunch of things go away. And again, I'm trying to do baby steps, right? So then I'm trying to rewrite. LCD, yep, that factor denominator. Okay, so now I'm rewriting, right? X squared plus 5x plus 12 equals a times that quadratic plus bx plus c, oops, parenthesis, times x minus 1. Yes, everybody with me? Nice way to start is 1, right? Because it will kill one of my pieces. So if I let x equal 1, I know that bx plus c is gone, right? So I get 1 squared plus 5 times 1 plus 12 equals a times the same thing, right? No, yeah. Oh, yeah, plus 4 plus 13. Okay, good. So I get 17, 18 equals 18a. So a is 1. And I try to make coefficients nice, that's in quotes, but if you're organized, everything should be fine. Now watch what I do here. I want to rebuild this thing I call a generator, right? Because I've got now x squared plus 5x plus 12 equals x squared plus 4x plus 13, right? So you can see I can really clean this thing up quite a bit. Oops, plus. If I combine like terms, right? Because my x squared terms are going to go away, right? So I'm going to get what? X minus 1 equals bx plus c times x minus 1. So I'm just, if I do that, right, once I get a value for something, I can make my life a little bit easier as I move forward. Good, Noah, what'd you pick next? Did you pick another value? Oh, okay, yeah. So once I put my value of a in, right, then my right hand side simplifies just to 1 times that factor. So I put that in, and then I subtracted x squared from both sides. They went away. I subtracted 4x, so I got x. I subtracted 13, so 12 minus 13 is the negative 1. So now I'm not looking back. I'm not going back to that other generator because it's messy. This one's a lot cleaner. And I can certainly pick x equals 2. And I end up getting a 2b plus c equals 1. So there's the first part of my system I'm going to get. I like x equals 0. Yeah, it might have been better to do that first, because now I see that c is just 1, right? Nice, so I got a is 1, c is 1, now I can find b, right? So b is 0. How are we doing there? This takes practice. You cannot just watch me do it. You can't watch me parallel park and then parallel park as well as I do. You can't watch me play guitar and then play guitar as well as I do. You can't watch me watch TV and then watch TV as well as I do, because I practice every day. So you have to get in there and do it, okay? And come up with your own organization method. Come up with your, do you want to keep going back to that original generator? Do you want to create a new generator every time? You know, it's all your choice. So I look at my original integral now, and I know I have 1 over x minus, right? Can I jump to that here? So I had the original integral, but now I know it's 1 over x minus 1 plus, and remember my b was 0, right? So bx plus c is just a 1. C was only 1 over the x squared plus 4x plus 13. Is that okay, what I'm doing here? Everybody's following me. I had the original integral, split it, I came up with the two fractions, partial fractions, and each of those becomes an integral. And of course, my first one is just the ln of x minus 1, right? You probably learned that in Calc 1, right? I hope you did. So if I have y equals 1 over x, or y equals 1 over x minus 1, you can see that it's just the same graph shifted. So meaning the area is just shifted. So meaning the antiderivative is just shifted, right? So the first one, right? The first one would be ln of x. And so then I'm just shifting it. So it's ln of x, with the shift, right? Is that making sense? Or you could do a u sub, but you'll quickly see, oh, u is x minus 1, du is dx. Okay, done, right? 1 over u, it's 1 over u. The other one, as I'm going down my list, I realize nothing's working. I can't factor it. It's not partials. So I'm thinking, next thing on my list, it's an arctan. I know it's an arctan because there's no square root. That would be the arcsine, right? So I'm trying to work on this piece here. It looks like I should probably complete the square. So x squared plus 4x in parentheses plus 13, get half of the coefficient of 4, which is 2, square it, which is 4, add it, and subtract it. Now, I'm thinking of I'm looking at my formula sheet going, okay, I think this is an arctan because Robert said he was going to put an arctan on there, right? And I'm going, all right, if y is arctan of u, y prime is u prime over 1 plus u squared, right? So obviously I don't want the 9 there. So I'm going to divide every term by 9. Yes, you with me? And that's looking more like what I want. 1 over the quantity of 1 plus u squared, right? So, but I can see I have a complicated interior, so I need a u sub again. So if u is x plus 2 all over 3, du is 1/3 dx. And I have that in the 1/9. And don't let me go too fast. You're paying me. So I see my 1/3 dx, that's my du, right? And downstairs I have 1 plus u squared. At this point, I don't need to, and it's up to you, I don't need to put it in as a u sub now. I know I've got a du, I know I have a 1 plus u squared, so I know I have an answer of arctan of u, right? And I'm done. Now, what's nice on the test, right? What's nice on the test is you could take the derivative of this and show that you get back to the original integral, right? Do you want me to do that? Yeah. Yes, I have mad zooming and scrolling skills. Here's the whole thing. If it's too small, let me know. I'll zoom in on a line for you if you want. Yeah. Okay, so here's my thought process. Nothing seems to be working. A U sub doesn't work, etc. Right? Yeah. So I complete the square.
I always think I had a negative 9 on
Oh, okay. Yes, yes, yes. Yeah. Wait. So that's line one. Is what you're saying? Line one or no? In the previous page? Yeah. So tell me where though. I'll give you some lines. 8, 3. Yeah, so remember what we did there. We multiplied the original line 2 by the LCD, and factors cancel, and then I'm rewriting. Real careful to rewrite. And then I'm just picking x values. And I ended up picking 0, 1, and 2. Yep. Another nice way to check this is to turn these problems into areas, right? So, but that's a little tricky because you got to pick something in the domain. You got to be careful about that. I think it's better for you and your future in math classes that you're practicing derivatives. Okay. So if I put it on there, check it using a derivative, and you don't do it, you lose points. If you get it wrong and don't have a check, you get more points off. I had a teacher that you could get a negative score on his test. If you didn't know how to answer it, don't answer it. Because if you got something wrong, if it was worth 10 points, he'd take 15 points off. Oh, he's evil. But I'm expecting you to get it right. Right? And then if you do your derivative and it turns out wrong, that's when you're not going to panic. You're going to possibly do your derivative over again, make sure. Then look at your integral, make sure. Then probably do the integral over, right? So if I give you 10 problems, you have time to do that. You have time to turn in a perfect test. Some of you do need to practice speed a little bit. So I'm saying pick a problem, set the timer for 12 minutes, right, on your phone. When you take your exam or you take your quizzes, you can listen to music. So if someone else is distracting you or you just have study music like I did, I think it's good brain recall. So you should be, like I say, I had one student last semester that took forever to do things, and I'm saying, well, you're listening to music, right? Well, after the third song, you should be going, I probably am on this problem too long, right? So whatever you can do, but you got to find your weakness and work on that. And of course, it sucks because we don't want to do that. We're humans. We want to do things we're good at. I don't go bowling. I hate it. Anything I have to change my shoes to do, I don't like to do. But I'm just saying, if I practice, I'd probably be okay, right? But we don't like to do that. We don't like to practice things we're no good at. But that's what you have to do as a student. I'm going to do one more and then we'll take a break, okay? What are you thinking about partial fractions for the quiz today? If you want, I'll give you no quiz today. I don't care. I just got to talk. Let's just do no quiz and then move the exam. That's better. I know. But if you're ready today, you'll be ready Monday. So, in fact, you'll be more ready. So if I move the test, I think that's the best thing. I don't like Monday tests because I want to get. I was so anxious when I took an exam. I wanted it back as soon as I could, even though I knew what I got right or wrong. Um, so I like to test on the last day, so I have a weekend to grade it. I feel too much pressure if I give you a test on Monday and we have class on Tuesday. And it's all about me. At least that's what it was. I thought I heard that in my music lesson. I heard me 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 me. So this will allow me to quiz up to 6.5 before the test if I move the exam. So I'm moving the exam to 6:23. That sounds right. Are any of you planning on failing the class? Any of you feeling like you're going to fail the class? No, right? Am I right? No? And remember, getting a low grade on a quiz is fine because you just make sure you fix that before the test, right? Okay. All right, I'm going to move the exam and then I can get more quizzes. I can quiz all the way up to chapter 6 that you'd be really ready for the first exam. I'm expecting no lower than a B from any of you. Okay? A's and B's is what you should all be getting anyway. You want to maximize your GPA so when you transfer, there's money for you. You want to get into the Phi Theta Kappa Honor Society and then start taking honors classes. If you take an honors class and you get an A, they give you $600. If you take an honors class and get a B, I think it's $300. Cash. All right, one more problem, then we take a little break. And this was going to be the problem if I gave you a partial fraction quiz today. And I imagine that you would have not been happy with me. But I have an ex-wife, so I'm used to it. So here's our partial fraction problem. And what are you muttering to yourself right now? How the hell do you factor that, right? So you remember that AC method, 2 times 3 is 6. And then I'm listing the factors of 6. Right? Both positive or both negative, right? And then is that right? Oh, did I screw up? I screwed up. Damn it. What did I do? Oh, yeah, I screwed up. Minus 5x, sorry. Let me fix it and we'll do it after break. So let's take a break. It's 9:40. Let's come back at I might need 20 minutes, so let's just say 10 o'clock.